What's up YouTube? We're continuing our Blind 75 series with another question about arrays. If you're new to the channel, we're solving one question per day from the famous Blind 75 list of LeetCode questions. Today we have another easy level question. It's called Maximum Subarray, and here is what it asks. Given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. A subarray is a contiguous part of an array. From our examples, we see we have this nums array and the output should be 6. The explanation says that the longest contiguous subarray is 4, -1, 2, 1, and it has the largest sum, which is 6. And the same is true for the example 2 and example 3 as well. So let's think about how we can solve this. Let's go for a brute force solution first. Well, to get the largest of anything, all we have to do is check every single version of that thing. So what we want to do is try and get every single subarray, and we're just going to compare the total to a running total that we have. If it's bigger, we reset the value to that number, and if it's smaller, we just keep the exact same value. So let's start. First, we need an integer to keep track of the max, and we're just going to set that to integer.minValue. And next, we just want to have a double nested for loop. So we're just going to do for int I equals 0, and we're going to loop while I is less than nums.length, and of course increment I. And for our other loop, we're just going to do int j equals I, while j is less than nums.length, and we'll just increment j. So before we enter the nested for loop, we just want to set up a new window max, which is just going to keep track of the maximum number in the window that we're looking at. And inside that nested for loop, we just want to reset the window max to window max plus nums at j. And next, we're just going to reset max to whichever is bigger. We're going to go with math.max, and we're going to check max against the new window max. And finally, when we've broken out of both of them for loops, we're just going to return the max. And let's submit that. And the answer's been accepted. But of course, this is very, very slow. This actually has a runtime of big O of n squared, which is super slow. And we got to think about if there's a way that we can get this down to big O of n. Well, there's actually a somewhat famous algorithm that we can use called Kadane's algorithm, and it's an iterative dynamic programming algorithm that calculates the maximum subarray ending at a particular position by using the maximum sum subarray ending at the previous position. So we're already somewhat implementing this in our nested for loop. All we need to do is change it up a little bit so that every time we loop through an array, we would continue to add the value at the current index to the window max, and then again check to see if the max is bigger than the window max. And then finally, if the window max is less than 0, we can just reset the window max to 0. Let's take a look at how we can implement it. So we just want to set up that window max and initialize it to 0. And we're going to iterate through our array. And then we're going to set window max equals window max plus the value at the current index. And then just compare max to the current window max. And then finally, if the window max is less than 0, we just want to reset the window max to 0. And let's run that again. And we can see our answer has been accepted. And that rounds off yet another day of the Blind 75 challenge. If you're enjoying the videos, please like and subscribe, and I'll see you tomorrow for another question.